This is a quick demo of the fixed store or core store, which is available in the PleX emulation. Now up to now I've been looking at toy A and toy B, and as we've seen, all programs are lost when you power off. But the third emulation, called PleX, contains a small region of fixed store which retains its contents after a power off. There were many different ways of implementing non-volatile memory. Some systems used devices such as ferrite cores for each bit of memory, hence the term core store, and their magnetic fields would retain the on-off state when powered off. The whole store could be made out of these, as they could be written to and read as normal, albeit a lot slower than volatile memory made from transistors. Now other systems had a combination of memory types, fast and volatile for the bulk of it, but with a small portion hardwired offline with the instructions and data for a bootstrap. And this is the method simulated in PlasMa, using the first 16 words of memory as the fixed region. You simulate the wiring by using the load switches as normal, just like any other location, but the difference is that this is the only way of altering these locations. If a program tries to write to those addresses, nothing happens. So this makes it a read-only memory, or ROM. Okay, this demo is in two parts. I'll first write and test the small program in normal volatile memory, which now starts at address 16, or hex 10, which is just after the fixed store region. Okay, I'll just go back to PC address 10, which is here, which is address 16, and just make a note of the first couple of instructions. The first one is B01A, and the next one is B104. Okay, back to address 10, which is the start of the program, and press run. Right, it doesn't do a lot, just a simple text display. Right, now I'll switch off and back on again. You see the registers and the store, although you can't see it, is random. I'll reload microcode 3. Right, we'll go to address 10. There's 10. And the instruction here is a 49ED, which is nothing like what we had before. So as you can see, the instructions have gone, which is as expected because the main store is volatile. Let's look at the next instruction, just out of interest. And there we go, 7CO. Okay, I'll program the same instructions into the core store this time. So set PC to 0, which is the start of the fixed region, and use the load switches as before. Okay, just for reference, the first two instructions, address 0, we've got a B00A, and the next one is B104. Now you may have spotted the first instruction is slightly different than before, even though it's the same program. It was B01A, and it's now B00A. And it's different because the program has been assembled for a different part of memory. So the address part of the instruction, which was OA, is 16 or hex 10 different from the other one. Now this raises an interesting topic of how do you move or relocate programs without reassembling, but that's one for later. So let's press reset. PC is 0, which is where the program starts. So there's no need to adjust it to address 10 this time. Press run and it should run. Right, now for the real test. I'll power off, back on again, load microcode 3, check the first few instructions. Address 0 is B00A, address 1 B104. That's looking good. Press reset and let's run. And the message appears again. Right, this fixed region can be used for whatever you like. It could just hold fixed data items or instructions or both. And typically you would use it to hold a loader program which loads programs from one of the peripherals. We've seen paper tapes in a previous video, and I think the next video I'm going to show mag tapes. And the challenge is to squeeze something workable into the 16 words. But if you can do that, you can always use it to load a more glorified loader with full error checking or operator prompts and so on. Okay, I'll leave it there. This is just a proof of concept, and I'll demo a loader program in a future video. So see you next time.